Hello, folks! Welcome you all to Brainy Bites YouTube channel. This is your mentor, Noah, and in today's video, we will begin with Class 7 curriculum, Chemistry, Chapter 1, that is, Matter and its Composition, discovering the building blocks of everything around us. Yes, today we will unlock the invisible blocks that shape our universe. You see this slide? A perfect example of all three types of matter in one picture. With this, now let us take a look on the learning objectives. Today, we will first understand the definition of matter, followed by the characteristics of matter, including mass and space occupation. Then we'll explore the composition of matter, along with the arrangement of these particles in solids, liquids, and gases. So stay tuned till the end of the video. Okay. Look around you. Everything you see, the air you breathe, the water you drink, and the stars in the sky is made of matter. By definition, matter is anything that has mass and occupies space. But be careful, not everything is matter. Things like light, heat, sound, and electricity are forms of energy. They don't have mass and they don't take up space. The question is, why? Let me give you an example. Take a glass of water and add marbles to it. You will observe that the level of water rises, whereas if you strike light into water, you observe no change in the level of water. And this clearly proves that light is a non-matter, as it neither have mass nor require any space. Now, let's understand the characteristics of matter. Just think, how do we prove matter has mass? Imagine a simple experiment. If you hang an empty can on a spring balance and then fill it with water, sand, or pebbles, the pointer is going to drop, faster than my grades during a surprise test. This change in reading proves that the substance has mass. Therefore, we define mass as the amount of matter it contains. The more matter an object has, the greater is its mass. Next, let's take a look over how matter occupies space. Imagine a glass filled to the brim with water. When you drop a stone into it, the water overflows. This happens because the stone takes up space that the water previously occupied. It's like trying to fit one more person in a packed elevator. Someone's gotta go. Okay, now we're settling the ultimate cosmic breakup: mass versus weight. First, let's talk about mass. Mass is the quantity of matter packed into you. It's your inner stuff. The best part about mass? It's loyal. It does not change no matter where you go. On the other hand, there's weight, which is defined as the gravitational force with which a planet like Earth pulls an object toward its center. Since weight depends entirely on the strength of gravity, it changes from place to place, whereas mass is a fundamental property that never varies, even if you travel from the Earth to the moon. So if you want to lose weight instantly without giving up pizza, go to the moon. Because the moon's pull is weaker, you would weigh only 1/6 of what you do on Earth. Now, let's deep dive into understanding the concept of composition of matter. Matter is made of tiny, tiny particles called atoms. Some atoms are loners, but most like to team up to form molecules. In simple terms, atoms are the building blocks of matter. They are the smallest unit of matter that maintains the property of an element. Atoms usually do not exist independently in nature, while the molecules are the independent ones that can exist on their own. A molecule is the smallest particle of a substance that can exist independently and retain chemical properties. For example, 2 hydrogen atoms combine together to form one hydrogen molecule which can exist on its own and retain its own chemical properties. They are constantly in a random motion dance, never sitting still for a second. Voila! Now it's time to discuss about the hidden forces and spaces that binds these molecules together. Yep, the intermolecular forces. As the name suggests, the forces present in between the molecules due to which they're held together is known as the intermolecular forces of attraction. It is due to this force that determines how close molecules are packed together in a substance. More the attraction between the molecules, lesser the space between the molecules of a substance, which is none other than the intermolecular space. Here, you see this example of a seesaw. It describes best about their inverse relationship. That is, as the intermolecular force decreases, the intermolecular space increases, or vice versa. The important thing to note here is that the strength of this force and the amount of space vary depending on whether the matter is a solid, liquid, or gas. So, the golden rule: the more the molecules attract, or force, the less room, or space, they have to hang out. Let's unlock these jars to know about each of the 3 states of matter. First up, we have solids. The molecules in solids are closely packed, and they have a definite shape and volume. The intermolecular force of attraction is at its maximum, while intermolecular space is the smallest. This is why you can't just squish a bowling ball. There's simply no room left to move. Next, the liquids. These molecules have moderate feelings for each other. The intermolecular force is weaker than in solids, allowing molecules to move, flow, and take the shape of the container. They have more intermolecular space than solids, so whenever you stir sugar into water and the level doesn't rise, it's because the sugar molecules are literally tucking themselves into the gaps between the water molecules. Finally, we have gases, the kings of social distancing. They have the weakest intermolecular forces and the largest intermolecular spaces. They have no definite shape or volume. This is why you can smell perfume from across a room. Those molecules are using that massive space to fly everywhere. Here are some fascinating facts about matter. The invisible matter, the air around us, even though invisible, is matter because it has both mass and volume. Shape-shifting. You can prove air has volume because the air inside a balloon occupies space and gives the balloon its physical shape. Electric energy. Electricity is the flow of electrons, which have mass, but the actual flow of electricity is energy, not matter. So, next time you meet your friends, do fascinate them with these facts. Okay, let's check out this deep diver slide. First, we have vibrating solids. The molecules in solids do not just sit perfectly still, they vibrate slightly within their fixed positions. Next, we have high compressibility. Gases have large spaces between molecules, which makes them highly compressible and capable of expanding to fill any space available. Wow, this was something new to my knowledge. If you too loved it, do not forget to hit the like button. Now, let's take a look on the next slide. The holistic lens, understanding world beyond limits. See at this beautiful picture, it tells us about the universal matter. That matter makes up everything we can see and touch, from the tiniest drop of water to distant stars and the moon. Next, the sensory limits. When you hear your favorite song, you are experiencing sound waves traveling through the air, but these waves do not have mass or occupy space. The last but not the least is the big picture. That is, understanding the intermolecular arrangement helps us explain the physical nature of our entire universe, from flowing rivers to hard rocks. That sounds great. The beautiful thing about learning is that no one can take it away from you. Yippee! Now it's time to explore science and society together. This is my personal favorite as it tells you where your knowledge is actually applicable. So, first things first, daily life packing. We all have been there. You cannot add more clothes to a fully packed suitcase because the existing clothes occupy all the available space. The next is a case study. It says that if you place a large stone into a bucket already filled to the brim with water, the water will spill over because the stone requires space. Well, that's something useful for our day-to-day life experiences. Now it's time for a short recap. Here we have the chapter summary that furnishes you with everything you need in a nutshell. Matter is basically divided into 3 branches, that is, the intermolecular space, intermolecular force, and what it is actually made of.
You can take a screenshot of this slide as it will help you in revising the chapter in just no time.
The states of matter matrix. Here is all what you need to know about the 3 states of matter. Again, you are advised to take a screenshot of this slide, and not mine, although I am an invisible matter. This will help you to cover concepts more efficiently and effectively.
Bravo! We finally made it to the end of this journey of learning matter. We did a great job together, but let me remind you of the DPP and Detailed notes, whose link I have mentioned in the description box. Do check them out, practice well, and do leave a comment if you find it helpful. This is your AI tutor Noah, signing off, and we'll meet you with a new video new day. Till then, subscribe to Brainy Bites YouTube channel, and get notified as fast as lightning. Happy learning, students!